Today, we are going to talk about finding the area of a regular polygon. You would be fine with a square, you would be fine with a triangle, but when we get into pentagons, hexagons, all those lovely things, we need a formula, okay? Hey, boys, I don't know what's happening, but no. Okay, so we have two things we need to understand what they are. Number one, this right here, this red segment, is the distance from the center of the polygon to the side. It's called the apothem. Okay. Then, just like a circle, we have a radius, and it goes from the center to one of the vertex points. Okay? Oh my goodness. What does the apothem and radius create? What? Oh, right. Triangle. Okay, now, we could find the area of this triangle and multiply it by 2 times the number of sides, because that is how many triangles we could create, right? Well, we could do that, or we could condense it down to this formula, which is all this is doing. To find the area of a regular polygon, we are going to take 1/2 times the apothem times the perimeter.
Is the apothem like always in the middle of the segment?
Yes, because it's a regular polygon, so it's always going to go to the midpoint. Did you hear Derek's question? He wanted to know if this was always going to be at the midpoint. The answer is yes, because we will, this is for a regular polygon. It's not English class. I just put it away. You should have done that before.
I should have, but I
What's
didn't.
up?
So is the perimeter, if you like count on side, you'll see the
Yep. So we need to know 2 things. We need to know the apothem, and we need to know one individual side length so we can figure out the perimeter. Okay? Now, there are going to be a variety of ways that these problems get presented to us. So we're going to start with more of the easier kinds, and then we're going to work our way through what if they give us the radius and not the apothem? What if they give us the side length and not something else, okay? So look at number 1. We have a regular triangle, okay? We know that the area is 1/2 apothem times perimeter. What is the apothem? 7. Okay? If one side is 24.2, how do we find the perimeter? Multiply it by 3 since we have a triangle. $72.6? Okay. So what's our area? I heard. Do you agree with 254.1? Yeah. Augie, what's our label? Square feet. Okay, could you please find me the area of this? What is this? This is an octagon. Find me the regular octagon.
You just said that. That was all.
It's easy, bro. Dude, it's so easy.
All right. Brooke, what's the perimeter of the octagon? Okay. So 1/2 times the apothem times the perimeter. What? Did you get 851.2? Square centimeters?
Why is it square
Potato. Okay. That too. Okay, now, guess what? It's not going to be super often that you're going to get the apothem and a side length just handed to you on a silver platter. Okay? So, it is possible that you're going to have to create a right triangle with the apothem and the radius to find a measurement. Aaron. It does. Okay? Now, flash back to chapter 7. Remember that if we have a polygon, then the interior angle sum is n minus 2 times 180. Okay?
Oh, I remember that.
Yes. Okay, Aaron just pointed something out. This radius is going to split the angle into 2 equal pieces. It bisects it, okay? So that's going to help us know what that angle is. Okay? All right, so let's look at number 3. I only have the apothem. We need the perimeter also. Okay? So everybody with me, draw in the radius. Do I care what the radius is? No. What I want to find is this measurement right here. Okay? What kind of regular polygon are we working with?
Hexagon.
Okay, we have a hexagon. So we need to take n minus 2. We need to take 4 times 180.
720.
Okay, so all 6 of those angles are 120. All 6 of those angles are 720. So what's 720 divided by 6?
You divide by 2, right?
So it's 60.
This equals
6 minus 2.
N minus 2. Okay, so each of these angles are 120 degrees, which means this angle right here is 60. Hey, I like that. because we know the properties of a 30, 60, 90 triangle, right? Okay. So Ollie is saying that x is 5 divided by radical 3, aka 5 radical 3 over 3, since 5 is the long leg and x is the short leg. Do you agree with Ollie's assessment here? Okay, I need to back up. Somebody asked about 60 degrees. Are you okay with where I got 120? Yes or no? Okay, so if this whole angle is 120, the radius is bisecting it, so half of it got me 60. What?
Can I do like tangent?
Sure. I think it's more work. Okay, now, if this is x, well, I mean, our answer is going to be a decimal, right? So let's do this. If it is not our final answer, let's round to 2 decimal places, okay? So what is x? 2.89. Okay. Which means in order to get our perimeter, what are we going to have to do with 2.89? Okay, we would have to multiply it by 2 to get a side.
Multiply that by 6. So
And then multiply by 6 to get the whole perimeter. So multiply it by 2, multiply it by 6. What's our perimeter?
69.36.
Okay, so I'm getting 2 different answers there. 34.68 is what I'm hearing more than. Don't type it in wrong, dear Rick. All right, so our area is 1/2 times the apothem times the perimeter. Now we can round to 1 decimal place for our final answer. 86.7 meters squared. Is there going to be a little bit of work involved? Yep. Sure is. That's okay. We're not scared of a little work. Augie. We are doing area.
Well, like, I see what you mean. Like, we already like, I don't know.
Are we gonna have to use the color?
I don't understand your complaint.
Are we gonna have to use the sign cost?
Okay. Here we go. Just everybody focus on me for a moment. In this part of the chapter, we're going to talk about area. We talked about area of circles, area of sectors, area of polygons squished together, area of a polygon, okay? So that after our quiz next week, we can talk about surface area and volume of 3-dimensional solids. Now, I know it feels like we're doing a lot of math in this just one problem, but you should feel thankful for that, because when we get to the final, you're going to be like, oh yeah, we just did these 30, 60, 90 triangles. I remember them. Oh yeah, we just went over all that trig stuff. It's good for this to come back. Because what did I say about that trig chapter? It's going to be part of every class you take. Okay. All right. Seriously? All right. Number 4. Let's look at number 4. Do I dare have you try number 4 without me?
No.
Oh, okay.
So N is the size.
Yes.
No, you should let us do it by ourselves.
No, Austin. No.
All right. Draw in your radius. Hey, we don't need any formula to tell us if this is an equilateral triangle. What is this angle right here? Which means this is 30. Okay. Ooh, hey. 18 is the short leg, so what's the long leg? Hey, you're welcome to do SOHCAHTOA, but I think that's going to take longer. Could you please put 18 radical 3 in your calculator?
1.06.
What?
1.06.
31.2. 31.2.
2 decimals.
31.17.
31.18.
Oh my gosh. Oh my gosh. Okay, remember, 2 decimal places. The square root button is this one, not that one. Okay. 2 decimal places if it's not our final answer. Okay. Did that give us anything we need quite yet?
Wait, why do you need 2 decimal places?
Okay, let me back the train up. I am asking you to round your final answer to 1 decimal place. So if we're rounding before we get an answer, I want you to round 1 extra 1 so that we can be a little bit more accurate with our final answer. Okay, our perimeter. How many 31.18s?
There's 6.
We need to double it to get one side. Then there are 3 of those. So our perimeter really is 187.08? Question mark?
Yeah.
Yeah, 0.06.
How do you guys
0.08. I did it without rounding, so I just like put it. Yeah,
Just let him be him. Okay. So now area is 1/2 times the apothem times the perimeter. Look at that. It's beautiful. It's a beautiful thing. Okay. Hey, I don't know why we get so out of control the minute we write down the final answer, but it's a little annoying. Now, those 2 are nice because they were 30, 60, 90 triangles. Or for our apothem and side radius. Here we're not going to be so lucky. Okay? Let's go ahead and draw our triangle, and we know we need to find this length I'm going to call X. Okay? But we have a pentagon.
So 5 minus 2 times 3.
So if we take n minus 2 times 180,
I did 5.
isn't it 5 sides? So how many total degrees are in a pentagon?
540.
Okay. And so if we divide that by 5, then each angle of our pentagon is what?
108.
So each of these are 108 degrees, which means this angle right here is 54 degrees. Now, is that a special right triangle? No. Some of you are working ahead. I want you to be a little careful with that. Okay. So we are going to have to use, hey, what trig function to help us? The tangent, thank you, of 54 degrees is opposite over adjacent. So in your calculator, we're putting 10 divided by the tangent of 54.
Wait, how would you plug that into your calculator?
10 divided by the tangent of 54.
Oh yeah, because you multiply by x.
Yeah.
Wait, what's the negative?
That's when we need to find the angle. Okay, so we have 7.27 for x. Okay. Now, if I want the perimeter, we got 7.27, but that's just half of our side length. So we need to double that and then multiply by our 5 sides. So 72.7 is our perimeter. Are we okay with that? Okay. So now you guys, you're driving me bonkers. And I'm not talking about you. 1/2 times our apothem. What's our apothem? 10. Times
727.
which is okay. We need to look at 2 more types of problems, okay? Go to the next page, and I want to look at number 8. Because in number 8, we know the side length. Hey, that's cool. I know my perimeter right away, right?
Wait, so it's what I was just talking about.
No, it's not. Okay, what's our perimeter? Okay, our perimeter is 22 times 6, which is 132. But sad day, we don't know what our apothem is. Okay, so I'm going to draw in my radius. I know that this side length is what? 11. Okay. We already talked about this being a hexagon, and how a hexagon, we already figured it out today, has angles of 120, right? So this guy is 60 degrees right here. Oh, no problem, Bob. Our apothem,
So 8 equals
11 radical 3.
Oh, I did it upside down. The radius. Isn't it over 3? Oh, no, no, it's not. It's just times right. Never mind, it's not the line. You're right.
I'm always right. It's cool. The radius is 22, but we don't care about the radius, unfortunately. Okay? So, our apothem is 19.05. So, for our area, we're going to take 1/2 times the apothem that we found times the perimeter.
You finish first, but you're always wrong.
Okay. Now,
No, it's kidding.
are you okay with how we got everything?
Oh, I got point.
You got 0.5? Okay, cool, sorry.
So much for Sorry, I was See,
Is that the only one that got point?
Yeah, you got a problem.
but
I did too.
I got 0.3.
I got point three.
Point 3.
So did anybody just, instead of 19.05, put 11 radical 3? Then that's probably why you got 0.5.
oh, my fault.
It will be, no, you would not be wrong. If you show your work, you will not be wrong. Okay. Now, let's go to number 14. What's given to you in number 14? The radius. So we have nothing that we need. We need to make 2 calculations. Okay? That's okay. Hey, we already talked about a pentagon having angles of, was it 108?
Yeah.
Okay. So what we're going to do is we're going to come up here. We're going to draw our apothegm. I'm going to call it A. And we're going to need to find X to help us with our perimeter, knowing that this cute little angle is a 54-degree angle.
Oh, no.
So we're going to have to do trigonometry how many times? Twice. Okay? Let's find the apothegm first. Which trig function do we need? Okay. The sine of 54 degrees is A over 19.
I got it.
Are we good with that? Okay. Okay. Now I need to find that X so I can find my perimeter. Which trig function do we need for that one? I mean, you can, but the cosine of 54 is X over 19. That's an easy thing to put in your calculator, isn't it? Okay. 19 times the cosine of 54 gives us
11.17.
okay? So our perimeter, you guys, settle down. We have 11.17 that we're going to have to double to get our side length. How many sides are there? 5. So now we have everything for our area. We have 1/2 times our apothegm times our perimeter.
Wait, you got 1.7?
Doing it you?
Wait, yeah.
You multiply by 10?
6, 7. Wait, I got 158.
So you're gonna get 850 divided by 2. 850.